0.732 minus 3. What's the value of x? Write it on your placard. First person up gets a beanbag. Oh, quick fingers now. All right. Yeah, I'm going to say close enough. I'm going off of what I have. All right. So, what did everyone encounter in terms of problems with that? Was it doing negative? Was it getting a value of the square root of 3? Because we spent a little bit more time on that than you would want to spend on the NETA exam. This is something that you want to punch in and get in less than 10 seconds. So, and this is not an indictment of you. This is you getting used to new hardware that you got in front of you. What was the slowdown with you? What challenged you as part of that?
Specifically calculus, yeah.
Well, just in general, yeah.
Gotta get another mode to actually do the square root.
Because yeah, it's not solving the square root. Like when I entered square root 3 and hit enter, it just did square root 3 again.
Oh, okay. The super helpful answer that calculated.
Yeah, right. Square root 3.
Square root 3, dumbass.
No, I need the number form.
You need me to do everything for you? This is why machines will rule the world. All right. So, algebraic equation that took a little bit more doing in order to get to the solution that we have there. So, let's build on it a little bit more. I'm going to keep hitting you with the square root of 3, I think. So, 3 equals 3x squared. And no, that's just cruel. There we go. 4x squared.
Ooh.
Whoopty shit, right? I don't know if that's right. Let me solve it. Yep, sorry. You both have it right. Yep. All right. So you each get one for that. So, sorry, I was looking at that and I was looking at that 0.75. Why is that not resonating with me? I was solving in my head as 3/4. So, Mike, the answer that we had in this case is realistically, PEMDAS doesn't start to come into play until we're actually trying to compute a value. When we are just doing our algebraic rearrangement, we can do it in any order that we want. As long as we're doing it correctly on both sides of the equation, you can start wherever you want. Now, the more difficult thing here is trying to get that 4 away from the x squared if you're trying to take care of the square first. Mm-hmm. So in this case, in order to get rid of the 4 next to that, we divide by 4 on both sides. So we have then 3/4 is equal to x squared right there. Mm-hmm. And now we can take square root of 3/4 equals x in this case. So the reason I've been doing this is that PEMDAS does not actually make a difference. When you're doing your algebraic solutions for any given problem, it doesn't matter which order you do them in, as long as you're going to be consistent by doing them to both sides of the equation. Now, for any order that or for any operation that you're trying to undo, you're going to use the inverse of that. So if you are trying to get rid of two figures that are multiplied by each other, you have to divide. If you're trying to get rid of a positive number, you subtract. If you're trying to get rid of a negative number, you add. There we go. If you're trying to get rid of a square, you're going to use a square root. And if you're trying to get rid of a square root, what are you going to do? Square. There you go. You're going to square both sides of it just like that. That is the foundation of algebra. That is going to be what you need to be able to quickly and confidently do when you are taking the NETA exam. Now, for the most part, the NETA exam is not going to ask you basic algebra questions. Instead, it's usually going to be in the form of the power equations or the other electrical equations that we are familiar with that are going to be on the NIDA formula sheet, or the other variables that we're going to potentially come across as we are solving for these different terms, these different variables, these different values that we have in our system. So, with all of that understood, let's bring this into the real world, and let's start talking about how this actually functions with the work that we are doing. And yes, there will be more opportunities. We're coming down to the last 20 minutes or so of our class. Time flies, right? But I want to bring this through to what we actually do with the work that we do day in and day out. A megger is formally known as what?
Megometer.
Megometer. It does what? What is the type of testing we do with a megger?
Insulation resistance.
Insulation resistance. So when we do insulation resistance, what are we actually doing?
You're injecting a really high voltage into, like, a breaker or something. You're looking for any discharges, which can be caused by, short or something.
So not necessarily discharges. We're looking for leakage currents. We're looking for the amount of current that's going to flow out of that. So that means our mega ohm meter, or insulation resistance meter, or insulation resistance tester, is going to use a calibrated voltage, and it's going to measure what? What is our instrument actually measuring? Exactly. But what is the...
It's going to give you resistance.
It's going to give us resistance, but it's measuring currents. Oh, hell yeah, Mike. Get a beanbag for that. No, because not everyone will say, like, yeah, it measures resistance. No, it doesn't. An insulation resistance meter measures current. It measures specifically leakage current. How much small amount of current is going to be flowing out of that sample in between 2 points that we have. So let's start by solving what we're dealing with. What are some common voltages when it comes to insulation resistance testing?
1000 volts, 5 kV.
Yeah. All right. Yeah, 1000, 5 kV. In fact, it's almost like the NIDA manuals somewhere in table 100.1 would give you values that you should be testing for, right? Another good item to have. The NIDA exam will rarely test you on just knowing raw values in the table, but I can promise you they will test you on table 100.1 because that is probably the most basic testing and the most commonly used table in all of that. Tom, read me out. What's the heading of table 100.1?
Insulation resistance test values.
There you go.
Electrical apparatus and systems other than rotating machinery.
All right. So you are going to test a medium voltage circuit breaker. Let's say it came out of a 15 kV system. So first of all, tell me what your test voltage is.
2500.
2500 volts, AC or DC?
DC.
How do you know that?
Because it says